the next part, we will begin to talk about the WLAN redundancy. This one also is very important, right? Because especially in your network, you choose to fit AP and AC together. In this scenario, if our AC is broken, that means the network cannot work, right? Because all the AC need to be for the traffic from the AP, and also you use the local forwarding. If some new AP is added in the network, we also have to get some information from the AC. And how to provide the redundancy function? We have lots of technologies. One is hot backup, and another one is VAC. And the VAC is very similar like the VSU, like the VSU function of the switch. But the VAC is a virtual technology for the AC. And another one for hot backup. And also we will talk about the principle, the key configuration on the hot backup. And except this two, we have another backup we call is, you also can call this is we can call this is like the active standby devices. This one we call is the cold backup, something like this. If one AC is broken, we try to establish the connection with another AC, but this time is too long for us. So that's why we skip this backup way. We only talk about the hot backup and the VAC. And the first one, why we need the AC redundancy? Like this topology, we have only one single AC, and all the switch for the traffic, or the AP help us to follow the traffic. We need to follow the traffic to the AC and then to follow to the destination. If in this process the AC is broken, that means the traffic will be discarded because we don't have the AC. This link is broken. So we want to establish the redundancy network in our topology. And if one AC is broken, we still can have another AC to help us to follow the traffic. And how to make the two AC can work together, and if one AC is broken, how to immediately let the other AC forward the message. And we have to add the configuration of the ACs. One scenario is if if you don't add any configuration, one AC is broken, and the AP when the time is over, and we will ask the DHCP to give us a new IP address, and from the DHCP, I will get a backup configuration of the AC and the connection with AC again, and then to establish the tunnel to get the configuration of AC and forward the message out. So in this scenario, we need a long time. And the first step, you have to find the AC is broken. And the function of the hot backup means now in our topology, we have one AC and another one AC, AC1 and AC2, and they will have loopback address. Of course, of the well-known network, we have to add the basic configuration of a VLAN, static route, something like this. And the special configuration for the hot backup is like this. About AC1, we will add the configuration of WLAN hot backup. And here is the IP address of the loopback address of AC2, 2.2.2. And this is a contact number, contact 10. And then this is a hot backup information for AP group Ruijie. Of course, we have to add the AP into the Ruijie. And about this hot backup, AC1 priority is level 7. About the priority, value higher is better. And the DHCP pool for the station. And then the VRIP interface VLAN 10 in the group 1. This is the configuration of the VRIP. And we have to enable the function of the hot backup. And about the AC2, we also add the hot backup for AC1, 1.1.1.1. But the different one is we don't give the priority. The default priority is 4. And the AC1 has higher priority than AC2 for the AP group Ruijie. And then between AC1 and the AC2, according to the priority, we will select AC1 as the active AC, and AC2 is a standby AC. Between AC1 and the AC2, they will have the hot backup keep alive channel. And about this channel function is, I will send out the message, and I will send the message out all the time. The default time is 1 second. I remember. This function is to detect my site is working or not. Otherwise, maybe the standby active will direct it to become the standby switch. The standby AC will immediately to become active AC. So this is the first function. The second function, the active AC will synchronize all the AP information to AC2. The function is, if active AC is broken, the standby AC can be a new active immediately. And then I also have every information from the origin active AC. So I can provide the service immediately for the AP. So this is a function of the keep alive channel. And how to establish the channel? That's because we add the hot backup configuration on AC1 and AC2. And another one is, now we add the configuration of AC1 and AC2. The question is, which address on AC is used to establish the tunnel? And how are the active and standby ACs negotiation with each other? Which IP address? On the WLAN hot backup, we can directly to design the IP address for AC2. I will establish the channel with 2.2.2.2. And another one, if the AC2 has the other IP address, like the physical address, we also can establish the channel with the physical address. We only have to add the configuration here. WLAN hot backup and 192.160.120.100. This is the IP address of AC1. We will add the configuration on the AC2. And I will use my IP address of 120.110 to establish the channel with my neighbor. So we also can use the other IP address to establish the tunnel. And then they will send out the message to do the negotiation. For example, the contact VAN number is same or not, and compare the priority finally to decide AC1 to become active and AC2 to become standby. This is a key configuration on AC1 and AC2. And the next one, after the AP connect with our network, we have to establish the CAPWAP tunnel, right? And the tunnel now, pay attention, we have to establish two tunnels, one for the active tunnel and another one for the standby tunnel. This one also is very important. But as we know, when we deploy the DHCP on our network, we will use the option 138 to let the AP know the AC information. But about the option 138, we only have one IP address, right? So AP only will establish the connection maybe with AC1. And how to let the AP know? We also have the backup devices, AC2, and we have to establish with this tunnel also. We have to establish two tunnels, and we will add the command. According to the contact 10, this is the contact of the AC, of the AC, and on the contact, we will add the peer IP address 201.18.90.1. This is the IP address of AC2. That's because when AP gets the configuration of the AC, I also will get the configuration of the hot backup. In the hot backup, because AP located in the AP group Ruijie, and in this group, we will add the contact 10. That means I also will know on the contact, we also have another devices The IP address is 201.18.90.1. I also will establish the relationship, the tunnel with this IP address also. Of course, this IP address must exist on your real network and they can communicate with each other. So this is a function how to establish two tunnels with each other. And then establish two tunnels successfully. Now when the client connect with the AP, and then the client information will be in the AC client, right? In the AC1, because I will record every client information from the AP. Then the AC1 will synchronize the station information for AC2. Also will synchronization the information for the AP. And the message sent out, this belongs to the control plane. When the station sends the message out, I only will forward the message to the active switch AC1, active AC AC1, and then the AC1 will decapsulate the message and send the message to the destination. And the next step, maybe the AC is broken. The AC maybe power is broken or something other one, and the communication is done. And 3 seconds later, the standby AC2 will detect it. And AC2 will become a new active devices. Then the tunnel between AP and AC2, the standby tunnel will become the active tunnel. And AC2 already has the information of station. Then the next step, if the terminal want to wait the resources, I can immediately send the message to AC2. And AC2 have everything of the station, so I can help to force the traffic out. So in this process, we only wait at least the time, the most longest time is 3 seconds. Because I only to detect that AC1 is broken, I will immediately to become a new active AC. And I already have all the resources from AC1, so I can help to force the traffic. So this is the step that AC is forced. And then if the AC is restoration, AC1 also can work. In this scenario, AC1 at the beginning will become the standby AC. And wait 10 minutes later, this is a default time, 10 minutes later, because the preemption mode is enabled. 10 minutes later, AC1 also can get every information of the station from the AC2. Then the AC1 will become a new active AC, and the AC2 will become the standby, because compared with the priority, AC1 has a higher priority. And this time is 10 minutes. 10 minutes later, I will switch the active again. And the 10 minutes is enough for AC1 get every station information from the AC2. Then the AP will establish the active tunnel with AC1 again and change the tunnel to become standby tunnel with AC2. So this is a process. And also we can provide the load balance backup in the AC1 and the AC2. The basic configuration is make AC1 as active devices in one group. For example, in the main group, in Ruijie group, AC1 is active devices, AC2 is a backup. And another group, the main group, we will make AC2 is active and AC1 is a backup. And how to control it? About the AC1, we will create 2 contacts. One for contact 20, the AP group is admin, and the DHCP is station, and the VIP configuration is here. And about the AC2, the main group, the priority is 7. So the result is AC2 will become the active devices for the group admin. And another one group for the Ruijie group. And I will make the priority to become 7. And another one for AC2, the priority we will use the default value. The default value is 4. So Later, we can add different AP into different group. The result is AP1 belongs to the radio group, and the AC1 will become the active. AP1 will establish the active tunnel with AC1, and the standby tunnel with AC2. But about the AP2, located on the main, and the AC1 will become standby, but AC2 becomes active. So this is a load balance. You also can, this is a double active and slave configuration. This is a hot backup. So the advantage of the hot backup is it takes only 3 seconds to complete the active and standby switch over, because every 1 second I will send out the keep alive message to let you I'm working. After 3 seconds I don't receive the message, I will immediately to become the new active devices. This is the default time. Also, if in your network, you will find your network is not stable and maybe the devices will up down all the time, you can shorten the time. For example, to become 10 ms. So the switch will be faster. Of course, you will need more resources to send out the keep alive message. Okay. And after, as the station data is backup, the service are not interrupted and the switchover is precedent free. So this is an advantage. And another disadvantage of the hot backup is management. 2 or more AC exist, the configuration modification or addition needs to be performed on all the devices, and you have to do the configuration one by one. The same configuration you have to add on AC1 and then log in AC2 to configure again. So this is a management limitation. And another one for the load. AP load is manually configured to different devices. Load balance cannot be implemented automatically, and this load balance based on your AP belong to which AP group. And all the AP in the same group, the traffic will be sent out through the active devices. Maybe in the real scenario, you only have one AP to connect with AC1, and you have 2 AP connect with AC2 as a backup as an active AC. But the real station is AC1 may be less station because not so much user connect with the AP1, but lots of message will connect with AP2 and then to let the AC2 to follow the traffic. So about the AC1, this is a waste of the resources, but about the working performance is too heavy for AC2. So this is the limit load balance of the hot backup. And another one for the license. The license cannot be shared. Each AP needs to have license corresponding to the number of managed APs. Also, maybe we have one AP and the standby tunnel and active tunnel connect with 2 ACs. One AC with at least one AP license. So maybe the physical AP you only have 20, but actually you have 40 license for the real devices. So this is the limitation of the hot backup, but we can make the time to very short to switch if the active devices is broken. And another one, the better solution is we can deploy the VAC in our network, like the function of the VSU. We can make the multiple AC to become virtually in the logical one AC. So the basic of VAC is very similar of the VSU. We also have to give the domain ID. If all the devices in the same VAC, the domain ID should be same. Like the left one, we use the domain ID 100 to indicate one VAC. And the range is from 1 to 255. The default value is 100. And in the VAC, how to distinguish different AC devices? We will use a device ID. And the default device ID is 1. Also same, different AC in the domain, the device ID should be unique. And another one is the AC priority, because in the VAC, we also have lots of rules. Who is active, who is standby, something like this. And how to select the rule, we will compare the priority. The active AC will have the highest priority, then is a standby, then is a slave. So this is a basic one. And we see we have three rules: the active AC, standby AC, and the slave AC. The special one is active AC will have the management plan. The management plan means, for example, you want to log in the devices to do the communication. You telnet the devices, or maybe use a console to connect with the devices. This configuration for devices itself, we will only the active AC can have. This is a management plan. And about the control plan each devices will have. That means all the AP management, we will buy the real physical devices to manage different APs. But if the active devices is broken, the standby active also can help us for the message for the AP. And the forwarding plan also each AC will have. We can help the AP to forward the message out. So this is the three-part rules, and the different one is active AC will have the management plan. And about the working mode, the default work mode is standalone, and we have to switch the mode to become VAC and let the devices to restore again, and finally to become in a new and in the same VAC. And between the devices, we also need one link. We call it VSL, the virtual switch link. And in the link, we will exchange the data between the member ACs and also detect that the status is active or not. This active device is working or not. This is very similar like the hot keep alive channel of the hot backup technology. And the function, the first one, we have to check the AC meets the VAC requirements or not. We will check the domain ID, check the device ID, check the device's version is correct or not, and finally to decide the rule. And the second one, according to the message, we will elect the rules of active, standby, or slave, or candidate AC. Then we will check the AC is faulty or not through the VSL link. And we will transmit the managed packets like the telnet, like the web configuration, SNIP packets through the VSL link, and then send to all the member switches. This is the function. And the requirement of the switch, this one is very important if you deploy the VAC in your network. Pay attention, you can directly use the VS link to connect with two ACs. This is working. But if you use one switch to connect with these two ACs, the first one, between the AC1 and AC2, they exchange the VAC message. This message is a special message, not like the Ethernet message. And this message cannot be fragmented. That means on the switch, you have to change the MTU value, the maximum transmitted unit, to become 9216. Because by default, the value is 1500. If I receive a big message, I will do the fragment to divide several bits. But about this message cannot do this function, so you have to change the MTU value to become 9216. And the other one, all the VSL packets are transmitted in the layer 2 network. So between this one, you have to design a VLAN special for AC1 and AC2 to transmit this message. And you cannot configure a layer 3 function here. You have to make the interface to become the layer 2. And in the same broadcast domain. Okay, for example, you can create a special VLAN only used for the VSL packets. Okay, so this is two parts when we use the switch to connect with ACs. And the next part, We suggest not only one link to connect with the switch as a VSL. If one link is broken, there's some mistake and some problem between the VSA. So at least two physical link, and you can add this link into the link aggregation group and to make the network stronger. So this is a limitation is very important. And another link for the service link. And this service link is used to help us to force the traffic out. And about the service link, we can provide the load balance. This also is a big parameter, big feature on the VSA, in the VAC, because we can use the load balance function. And about the load balance function, you have to enable one part is AC and the core switch, because this AC and core switch link, we have to force the traffic out. Another one for the distribute switch, this switch, we also have to provide the load balance function. So you can use the aggregation port, the AP port, and design the load balance based on the source and the destination IP address. So finally, the message will be sent out based on different IP and source and destination IP address, and forward the message out to use the function of load balance. AP1 sends the message, and finally the AC1 will help us to forward out. If AP2 sends a message out, AC2 will help us to forward the message out. And the configuration is like this. The first one, we have to decide which link for the VSL and which link for the service link. Like this topology, the red one is service link, and the blue one is the VSL link. And about the VAC parameters on AC1, you have to create the virtual AC domain. The domain is 1, and the device is device 1. The default device value is 1. And this device, the priority is 120. And about the AC2, the virtual AC domain should be same with AC1, is domain 1. And the device number is 2, and the priority to become 100. So the result, AC1 will become the active device, and the AC2 will become the standby. Then we have to configure the VSL link. On AC1, we have to create a VAC port and add one link, gigabit 01, this interface, into the VAC interface, and the same configuration of the AC2, add the interface into the VAC port. And about the switch, pay attention, we have to do special two configuration, one for MTU and another one to make the VSL link in the same broadcast domain. So we have to create a new VLAN, and this VLAN you can use every value except your real service VLAN, like 2024. And then your interface 1 and 2, one connect with AC1, one connect with AC2, right? Add the interface into the VLAN 2024 and pay attention to change the MTU value to become 9216. This is a physical interface. And you have to switch the format from the standalone to become VAC mode. The command is device convert mode to become virtual, and the same configuration of AC2. And after you enter this command, the devices will automatically restart. So in this process, the AC will not working at the time until we become a VAC successfully. Then you can use the command show virtual AC rule, and you can see two AC, AC1 and AC2, and the domain ID, priority ID, and now the position is local or remote, and the status is okay, and what's the rule, and what's the ID. And here is a configuration. And another one is we say the VAC, we can provide the load balance function. So the first one you have to create on the active AC, like create the aggregate port, then to switch mode to become trunk, and add the first interface 2, into the aggregate port. And pay attention because now you add this configuration, we already restarted it, right? And now AC1 and AC2 in the same VAP, in the same VAC. So if you want to add the link aggregation configuration, you can directly enter the special devices. Like the interface 2 of AC1, the value is 102. And you have to add this interface into the aggregate one. And another one for the gigabit interface. For AC2, the number will become 202. And then you also have to add the interface into the link aggregation port. So this is a configuration on the AC. You only add this configuration on one device is enough. Then you can use the command directly add the other devices configuration on the same devices of AC1. This is the aggregation configuration of the AC. And another one on the switch. On the core switch, you also have to create a link aggregation interface and switch the mode to become trunk. And add two interfaces, 3 and 4, connect the service link with AC1 and AC2, and add this interface into the group. And pay attention to add the load balance function of the core switch, aggregate port, load balance, source and destination IP address. And of course, pay attention, your access switch, you also have to support the source and destination load balance function. And later, when our AP online, you can use the command show virtual AC balance information. You will find now we have one AP on the device 1 and 2, and what's the license, what's the station number. This information is check the result for the load balance information. And here compare the hot backup and VAC, we have some difference. Compare the number of redundancy AC, the requirement, and the trigger and the switching time, the advantage and disadvantage compare with each other. Let's see some key point. About the number of redundancy AC, hot backup. The priority range from 0 to 7, and AC with 7 priority can conduct the preemption to become active devices. For the same AP, a hot backup instance allows only one active and one standby. For different APs, the active of an AP can be standby and another AP in the active. Actually, this is a double active and a slave connection. What about the AC? The number of ACs in different mode of the AC varies. For the same AP or different AP, only one active AC and one standby are allowed. Other AC will be slave, and also you can say this is candidate AC. And the requirement, mode and version requirement, AC can be in different mode, but the performance cannot vary much. The WS6024 does not support the hot backup, so your hardware must support the feature at first. And it is recorded as a version of ACs be same. Others, AP can interwork with the ACs, the active and standby AC can interwork with each other. And about the VAC, the mode and version are required must be same. AC in old mode does not support the VAC. It is recommended as the last version will be used. Others is AP can interwork with active AC. The switch needs to support load balance based on source and destination IP address. Otherwise, the load balance cannot work. Because the switch have to provide the load balance at first, then the active devices of AC can force the traffic beyond to different message. You mean the table for VSU, right? This one I have to find the document, and last day, maybe tomorrow or the day after tomorrow, I will send the training record and the material and this document compare with physical stacking, VSU, and MLAG same to you as with the material. As the FAQ, I will send the document to you. Okay. Yeah, this is a license. I will show you now. Here I also say the license here. The advantage of we can see step by step at first. The trigger and switch time, the hot backup, the active is fault or active and standby unreachable. The standby will take the places of active a few milliseconds without the service interrupt. And about the VAC, in case of an active AC fault or VSL disconnection, the standby AC will take the places of active AC. And another one for the advantage of hot backup is when the active AC is faulty, the service are not interrupted. So this one is very useful, and the redundancy is realized. About the VAC advantage, when the VA active AC is faulty, service are not interrupted. This one also is C. Without a uniform management, when AP is added, the active and standby AC no need to be configured together. We only add the configuration on one device is enough. And about the VAC, the licenses are shared. So this is your answer, I think. About the hot backup, the licenses are not shared. And the performance can be added and automatically load balance is implemented. And the disadvantage of hot backup is the licenses are not shared. And the central service are not supported. The built-in and first generation web authentication cannot be done for the hot backup. And about the VAC, the implement is very complicated. The AC need to be in modes supporting VAC. The core switch need to be support the load balance function. And the central service are not supported. That means about the VAC, we have several limitations of the service. So this is a configuration from the hot backup and the VAC. So that's all about the redundancy function. Any question for you?